Hello. Okay, so today we're going to look at the roots. Get rid of the square again. Okay. And you're like, why do you keep on crossing off the square when it's a square root? Yes, but you know what? It can get a little bit confusing between square roots and perfect squares. So we'll just say roots, okay, and squares, okay, perfect squares. So remember that perfect squares results in a whole number, a fraction, or terminating or repeating decimals, which are all known as rational numbers. Okay, so pretty much if we have a rational number, we're gonna have a perfect square. Hey, I think that just clicked for me just now. Okay, hey, that's awesome. Okay, so let's find the square roots, or let's find the roots of the following. Okay, so what number multiplied by itself gives me 121? Well, that's 11. Okay, that's a whole number. Okay. What number multiplied by itself is the root of 4/9? Okay, so what times what gives me 4? Well, that's 2. What times what gives me 9? Well, that's 3, which is the same thing as 0.6 repeating. Okay, so that's a fraction, an example of a fraction, or a repeating decimal. Okay, and what is the root of 1/4? Okay, well, what number times itself gives me 1? Well, that's 1. What number times itself gives me 4? Well, that's 2. Okay, or we could write this as 0.5. So that's an example of a fraction or a terminating decimal. Okay. So these are just reviewing what we've done already. Okay. However, not all numbers are perfect squares. Okay. What is the root of the number 10? So, step 1. Does it have a root which can be multiplied by itself to get 10? So I think about 10, 2.2 is 4, 3 times 3 is 9, 4 times 4 is 16, so no, okay, no. What are the closest perfect squares around the number 10? Okay, so perfect squares, so 3 times 3 is 9, okay, so we know that 3 squared gives me 9, okay, and what's the next one? 4 squared gives me 16. So the root of 10 must be between 3 and 4. This is known as using benchmarking, or as using benchmarks to find your estimate. And it's really, really handy. Okay. So if we take a look at our number line here, okay, so we know that 3, so we know that the root of 9 is 3, and the root of 16 is 4. So somewhere in here has to be the root of 10. Okay. So note, 10 is very close to 9. So a good estimate of the root might be, let's say, 3.1 or 3.2. Okay, these are just estimates. Okay, now if we use our calculator, let's try it out. Okay, so take your calculator, go root 10. Ho, 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 look at that. Okay, that's not that bad. Okay, so you got 3.162277766. Okay, what do we notice? What do we notice about the decimal? Okay, it doesn't repeat or terminate. Okay, if you look at your calculator, okay, it will just keep on going. Okay, turn the page. turn my page too. Okay, so this is called an irrational number. Non-perfect squares will always be irrational. And you will always have to round them. Okay, rounding makes your answer not exact. Okay, it makes it an approximate answer. We just have to be careful about that. Okay, so for root 10, we will round the answer to 3.16. So if I go back here, if I was going to round it to 2 decimal places, I'm going to look to the third number. That's less than 5, so that means the 6 can stay a 6. Okay. Okay, so 3.16 is an approximate square root of 10. Why? Because 3.16 times 3.16 gives you 9.9856. And you should pause and try this on your calculator yourself so you start getting comfortable with understanding, oh yeah, okay, I see, okay? So this is a non-perfect square. Okay, so let's try an example. Okay, we have a number line here. It says use benchmarks to estimate the root of 7.5. Okay, so let's take a look here and see what are our squares. Okay, so I'm going to write our squares here, and these are going to be our roots. Okay, so the 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Oh, and now I'm higher than what I needed, okay? So now I can just put root, 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 root. Okay, now we wanted the benchmark of 7.5, right? So what perfect square is 7.5 between? So if I take a look here, and 7.5 is going to be between 2 and 3. Oh, what perfect squares? Well, that's 4 and 9. Okay, what are their roots? Okay, their roots are 2 and 3. Okay, so let's draw a number line here, just a very short one. And we're going to go from 2 to 3. And in between, let's go, we'll do 10 little points, okay? So 1, 2.1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 3. Okay, so we want 7.5, right? So if we know that this is my root, okay, and squared is 4 and squared is 9, okay? So the root of 4 is 2, the root of 9 is 3, okay? Or 2 squared is 4, 3 squared is 9, okay? So now if we want 7.5, let's see, that's, oh, you know what? Well, that's okay. This is like 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9. So where was that 7 again? 4.5, 5, 6, 7, 7.5. Okay, so here is 7.5. Okay, that means my root is going to be 2.1, 2, 3, 4, 5, 6, 7. Okay, so we can clearly see that 7.5 is closer to 9. Okay, so the root of 7.5 is going to be closer to 3. So an approximate value of 7.5 is 1, 2, 3, 4, 5, 6, 7. Is 2.7. Okay, And if we take our calculator and figure it out, double check, root 7.5. Hey, that's not that bad. Look, 2.7386. Okay, that's not bad at all. Okay, so we just used a number line to help us out. Okay, let's use benchmarks again to estimate the root of 75. Okay, so 75 is between what perfect squares? So 75 is between what perfect squares? Okay, so let's look up here and we'll just keep on going here. 6 times 6, well, that's 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. Okay, here we go. Okay, so we know that 75 is going to be between 64 and 81. Okay, so now what are their roots? Okay, so the root of 64 is 8, and the root of 81 is 9. Okay, so if I drew a number line again, okay, I'm going to have 8 here, and then I'm going to have 8.1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here is 64. Here is 81. Okay, 75 is, where is 75? 75, well, let's see what the difference is here. 81 minus 64 is 17. Okay, so it means between here and here is 17 numbers. If I divide that by 2, that gives me 8.5. So halfway is going to be 72.5. Okay, so 75 would have to be, say, somewhere over here, maybe. Okay, so we could say that the root of 75 is approximately, that's what the little squiggly lines means, 8.6. 8.6. Okay, and that's how we can solve this without using a calculator. Okay, and I'll provide you with a whole, this whole number line so that you don't have to memorize anything, but you will find that you will start to know some of these off by heart. Okay, I like doing benchmarks. It's kind of a nifty way to get a pretty close answer. Okay, turn the page. Finding the closest square number. If you are given an approximate root, okay, you can easily estimate its approximate square number. Okay, so if the approximate square root is 7.3, find its approximate square number. Okay, so we're going to ask ourselves, what two numbers is 7.3 between? Okay, well, that's pretty easy. Take away the decimal place and we have 7, okay, and the next number up is 8. Okay, what are their squares? Okay, well, the square of 7 is 49, and the square of 8 is 64. Okay, what's the difference between them? Okay, so if I go 64 minus 49, okay, that gives me 15. Okay, so now I know that there's 15 numbers between 49 and 64. Okay, so now 1/3, right? Because we're doing 7.3. Okay, so 1/3 of 15 is about 5, right? Because 5 plus 5 plus 5 gives me 15. Okay, so for example, if I were to draw this out and I had 7, and again, 1, 2, 3, 4, 5, 6, 7, 8, 9 takes me to 8. Okay, so this is 49 here. This is 64 here. Okay, so I want 7.3. Okay, so approximately, the approximate square of 7.3 is going to be 49. Okay, plus, what's this area here? And if we said that this is roughly 1, 2, 3, so this was 5, 5, and 5, so then that could be 49 plus 5 gives me 54. Okay, and that's without using a calculator. Okay, and we could check it out and see 7.3 times 7.3. Oh, 53.29. That's not bad. Okay. So the important thing about this is we're trying to do this without using our calculator at all. That's what we want to get comfortable with. Okay. So let's do this next one as well. If the approximate root is 4.2, find its approximate square number. Okay. What two numbers is 4.2 between? Well, the smaller number is 4 and the large number is 5. Okay, so I'm going to right away draw myself a little number line here. 4.1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay. Their squares are, so 4 squared is 16. 5 squared is 25. Okay, so 16 and 25. Okay, and I prefer to do my math again in pencil, but it's harder to see on the videos. That's why I use colored for you. Okay, so what's the difference between 25 and 16? 25 minus 16 is 9. Okay, so if I look here, 0.2, so we're looking at roughly here. So 4.2 is 0.2 is about 1/5, right? So if I divide this into, let's see, 1/5 of 9, okay, is about, it's less than 2, right? Because 1/5 of 10 is 2. So let's say 1.8. Okay. So the approximate square of 4.2 is 16, right? Plus this 1.8 gives me 17.8. Okay. This takes a little bit of getting used to, but it's not that bad. And we'll try a couple examples again and see how it goes. Okay. Turn the page. So I have 3 questions here for determining how to estimate and finding our roots. Okay. So at the top of the page, let's just write out the roots so that we have them on hand right away. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and their perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and 121. Okay, so use your estimating skills to find these roots. So pause, try it yourself, okay, and then check your answers against mine. So maybe pause, try it yourself. Either try one and then check, pause, try the next one and then check, but whatever. Pause first, okay? So I'm looking for 60. So 60 is between here and here. So it's between 49 and 64. Okay, so I'm going to draw my number line. Okay, so I have 7 is the root of 49. 8 is the root of 64. Okay, and I want to have 60. 60 is going to be a lot closer to here. Okay, so if this is halfway, so this would be approximately 7.75. Okay, that's fair. Okay. Let's try the next one. So 90, okay, right here. So this is between 81 and 100. So I draw my number line. Oh, 81, 100. So this is 9 and 10. Okay. So let's see here. Halfway through would be what? Let's go 100 minus 81 is 19. Divide that by 2. So the middle here is 89.5. So if I want the root of 90, that would be about here. Root of 90, so let's say approximately 81.6. Oh, or sorry. Sorry, I want the root of 90, so it's approximately the number on the bottom, 9.6. Let's try that again. Sorry. You probably caught that before I did. Okay, root of 180. Okay, so this is between 13 and 14. Okay, 13 squared, 169. 14 squared, 196. Okay, what's the difference between these? So 196 minus 169 is 27. So that's 27. I'm going to divide it by 2 to get my halfway point. This is 182.5. Okay, so if I was looking for the root of 180, I'd say approximately 13.4. Okay, it's a little bit less than half. I always like finding the halfway point. I find that's a easy way to gauge everything. Okay, the next one is a fraction. Ho, this is different. Okay, so now we have to find the perfect squares for each of these numbers. Okay, so this is close to, what's the closest whole number, or the closest perfect square? By 8. So 8 is between 4 and 9, but it's much closer to 9. Okay, so root 9, and 5 is between 4 and 9, but much closer to 4. Okay, so 9 over 4. Okay, and that's the same thing as saying, okay, now I don't like that we're having to work sideways because I didn't leave enough space here to work down. Okay, so that's the same thing as saying 3 over 2 times 3 over 2, which is the same thing as saying root of 3 over 2 squared. Oh, is this looking familiar? Which leaves us with 1.5. Okay, or sorry, approximately 1.5. Remember? So if you have a fraction like this, all you find is you find the closest perfect square for the numerator and the closest perfect square for the denominator. And then after that, you do exactly what we've been doing so far. Okay. Number 2, given these approximate roots, write down the approximate square numbers and show all your steps taken to arrive at your final answer. Okay. So we have 9.7. These are the roots, and we want to find the squares. Okay, so 9.7, so first thing I start with the numbers that I'm in between, which is 9 and 10. Okay, so this is 81, this is 100. Okay, so I always set this up first. Okay, so I have my root, so I'm looking for here, around this 9.7. What is going to be my root? Okay, so I have 100 minus 81, so that's 19. 19 divided by 2 is 9.5. If I add that to 81, I get 89.5. Okay, so if I were to guess this, I would say my approximate square would be maybe 94. Okay, roughly. Okay, something between 100 and 89.5. Okay, roughly. Next one. Okay, 11.4. So I'm going to draw another number line here. 11 is on the small end. 12 is going to be on the bigger end. Okay, 11 squared is 121. 12 squared is 144. Okay, what's the halfway mark? 144 minus 121 is 23. Divide that by 2, so that gives me 132.5. Okay, I'm looking for 11.4. Okay, so that fits around there, which could make this approximately 130. Okay, something around there that makes sense. Okay, 130, 131, 129.5, something like that. Okay, so close by. Okay, and then the last one here is 5.2. So we draw our number line again. The lower number is 5. The higher number is 6. Okay, 5 squared is 25. 6 squared is 36. Okay, and what's the halfway point there? 36 minus 25 is 11. Divide that by 2. So the halfway point is 30.5. Okay, I'm looking for 5.2, so something over here. So approximately, what do you say? 27? That seems fair. Okay, not bad. Okay, so now we just took these numbers and squared them. Okay, we found the roots of these numbers. Okay, and the very last question says, identify the error in the following situation. Okay, it says your friend has asked you to help him out with his math. He wrote that the square root, so he wrote that square root of 6.4 equals 3.2. Can you see where he made his mistake? Okay, well, let's figure that out. Okay, so I'm going to draw a number line. Okay, and I'm trying to find the root of 6.4, right? So 6.4, I'm going to go back up to the top of my numbers. So it's between 2 and 3. Okay, so we have 4 and 9 are the perfect squares that are in between 6.4. Okay, and these are 2 and 3. Okay, and 9 minus 4 is 5, and if I divide that by 2, the middle is 6.5. So if I'm looking for the root of 6.4, okay, that's probably closer to 2.4. Okay, so what was his mistake? Okay, he just divided 6.4 by 2. Okay, he didn't find the root, he just took 6 divided by 2 and 0.4 divided by 2. Okay, so there we go. An approximate answer would be 2.4. between 2 and 3. Okay? I hope you feel more confident. Okay? I hope that you tried them first and then checked them against my work. Makes it a lot easier. Okay? We shall talk to you soon. Happy practicing.